differentiation of logarithmic and exponential functions. So remember going through logarithms in week 6. The natural logarithm is a logarithm with the base e. And we write that as here our ln, or log e of a. So that's our natural logarithm of a. And it's the inverse of the natural exponential function e to the power of x. So remember that our natural logarithmic function here is defined between integral between x and 1 of dt, x greater than 0 here. So we're using integrals. This will make more sense next week when we actually look at integration. So we look here, differentiation of the natural logarithm function. So here our derivative here of our natural logarithm is given by d on dx. Here our integral between x here of dt, or 1 on x. And we write it in general form, and this is the format that we'll see it often here. So d on dx of our natural logarithm of u is equal to 1 over u multiplied by du on dx. So we have some examples here. We'll start by writing the relevant formula at the top. We've got d on dx. Our natural logarithm of u is equal to 1 on u du on dx here. So if we look here, go through this step by step here, our u is equal to x squared. So we can use 1 on u. We see, okay, we're going to have to find du on dx. Du on dx here becomes 2x. So now our dy on dx of our natural logarithm of x squared here, is equal to 1 on u, our u is x squared, multiplied by du on dx is 2x. Becomes 2x on x squared. Here we cancel out one of our x's, top and bottom, becomes 2 on x. So going to our next example here. Again, we're going to start off by writing our formula at the top. We've got d on dx. Our natural logarithm of u is equal to 1 on u du on dx here. So if we write this one out, and here we're going to remember how our actual logarithms work here. So here our y is equal to our natural logarithm of x, the power of x. We can bring that x out the front. So it becomes x multiplied by the logarithm of x here. So dy on dx, we're going to be bringing our chain rule into this. So here we're going to be looking at, well, it's x times d on dx of a natural logarithm of x plus d on dx of x multiplied by the logarithm of x here. So x times, so here we've got our natural logarithm of x, so it's going to be 1 on x multiplied by du on dx. We differentiate x and we get 1. Plus d on dx of x, we get 1 multiplied by the natural logarithm of x here. So here x on 1, so here we're going to end up with x over x plus our natural logarithm of x. These will cancel out and give us 1 plus the natural logarithm of x. So again, we're going to start out, we're going to write our formula here at the top. We've got d on dx of our natural logarithm of u is equal to 1 on u du on dx. So here we look at this. We're going to write this one out because it's a bit more complicated, isn't it? So we've got u is equal to our x squared minus 3x plus 1. Du on dx, so here it becomes 2x minus 3. So now we have our u, we have our du on dx, we can work through this one here. Dy on dx will be equal to 1 on u, 1 on x squared minus 3x plus 1, multiplied by du on dx is 2x minus 3. And this is a fraction over 1, so here it's going to be 2x minus 3 on x squared minus 3x plus 1. So moving to our next problem, again, the first thing we're going to do is write our relevant formula at the top. We've got d on dx, a natural logarithm of u, is equal to 1 on u multiplied by du on dx here. And now we're going to remember our properties of our logarithms. So remember here, logarithm of one number divided by another number was the same as our natural logarithm here, x squared plus 2x plus 3 minus our logarithm of x squared minus 4x plus 5 here. So now we have some nicer numbers we can actually work with here. So now if we look at this one here, we'll change colours here. So here our u is equal to x squared plus 2x plus 3. du on dx will then be 2x plus 2. Here our u is equal to x squared minus 4x plus 5. du on dx then becomes 2x minus 4. So going back to our equation here, so we're going to find dy on dx here, and we have here our two different logarithms here. So here our first one, we're going to have 1 on u, 1 on x squared plus 2x plus 3 multiplied by du on dx is here, multiplied by 2x plus 2, minus here 1 on u is 1 on x squared minus 4x plus 5 multiplied by our du on dx, 2x minus 4. So here we're going to get 2x plus 2 on x squared plus 2x plus 3 minus 2x minus 4 divided by x squared minus 4x plus 5. So now looking at differentiation of logarithms with a base a. So here we've got a base a, so log a of x. And so long as our a is not equal to 1, we define it as the inverse of a to the power of x. So here we can go through remembering our change of base formula. Log the base a of x is our natural logarithm of x divided by our natural logarithm of a. So a here and our x here. So differentiating all of this, we can split them up and we end up with our rule here at the bottom here. Our differential of log a to the x is 1 over the natural logarithm of a multiplied by 1 over u times by du on dx. So if we follow this one through here, we're going to start here. We want to find the first derivative of y equals log 2 to the power of x. So we're going to start by writing out our formula. d on dx, here we've got log a to the x is 1 on our natural logarithm of a times 1 on u times du on dx here. And here, so this becomes our u is equal to x here. So that's our u. u equals x, du on dx is equal to 1. So we say, well, dy on dx for our log base 2 of x here becomes 1 on our natural logarithm of 2 multiplied by 1 on u is 1 on x multiplied by du on dx is 1. So this comes together is 1 on x natural logarithm of 2. So moving to number 2. We start again by writing out our formula here. d on dx of log a to the x should be u equals 1 on natural logarithm of a times 1 on u times du on dx here. And now we're saying, well, here's our u. u is equal to x squared plus 1, du on dx here is 2x. So now d on dx here we've got log base 4 x squared plus 1 here. So we say 1 on the natural logarithm of a, which is 4, multiplied by 1 on u, which is our x squared plus 1, multiplied by here du on dx is 2x. So we end up with 2x at the top, and here at the bottom we've got our natural logarithm of 4 multiplied by x squared plus 1. And moving along to our next example here. We start again, we're going to write our formula out over here. d on dx of log AU is 1 on natural logarithm of A multiplied by 1 on U multiplied by du on dx here. So now we're looking at it here. Our u is equal to x squared plus 1. Du on dx is equal to 2x. So now what we're going to do is our actual differential here. So d on dx, here we've got 4 log base 6 of x squared plus 1 here. So here we have 4 multiplied by here 1 on our natural logarithm of 6. Multiplied by 1 on u is 1 on x squared plus 1. Multiplied by du on dx is 2x here. So multiplying through, we're going to get 8x divided by here our natural logarithm of 6 multiplied by x squared plus 1. Next we're looking at differentiation of exponential functions. So exponential functions are the only functions which equal their own derivatives here. Given y equals e to the power of x, log of both sides, here we get log of y is equal to x, differentiating both sides, we end up here and we end up with dy on dx is e to the x. So d on dx, e to the x is equal to e to the x here. Or when u is a differentiable function of x, du on dx of e to the power of u is e to the power of u multiplied by du on dx. And this is the formula we're going to be using for most of our equations here. So here we're going to write out our formula. D on dx, e to the power of u is equal to e to the power of u du on dx here. Here our u is equal to x. Du on dx is equal to 1. So dy on dx here will be equal to 3 e to the x multiplied by 1 is equal to 3e to the x here. Continuing to our next question. Number 2, we've got y is equal to e to the power of 2x plus 1. So we write out our formula again. D on dx here, e to the u is equal to e to the u du on dx. So here our u is equal to 2x plus 1, du on dx here is equal to 2. So now dy on dx is equal to e to the power of 2x plus 1 multiplied by here du on dx is equal to 2. Becomes 2e to the 2x plus 1. So moving to our next problem here, we've got y is equal to e to the power of x squared. So we write out our formula again. D on dx, e to the u is equal to e to the u du on dx. Here we have u is equal to x squared, du on dx is equal to 2x. So now dy on dx here will be e to the power of u, so e to the x squared multiplied by here our 2x becomes 2x e to the power of x squared. For our further examples here, we write out our formula. D on dx, e to the u is e to the u du on dx here. So here we've got d on dx of x e to the x minus e to the x. So we've got to bring in our other rules from earlier now. So we're going to have here x multiplied by d on dx of e to the x here, plus here e to the power of x multiplied by here our differential of the x. So that's these two parts here, minus here d on dx of e to the power of x, which is this part here. So here we end up with x, and so e to the x becomes e to the x multiplied by du on dx, which is x becomes 1, plus e to the power of x, d on dx of x becomes 1, minus here we have e to the power of x here, and that becomes 1. becomes x e to the power of x plus e to the power of x minus e to the power of x. Here becomes x e to the power of x. And further examples here, we've got y is equal to e to the x sine of x. So now we look at it, we're going to use two different rules here. So we're going to write both of these rules out. We've got d on dx, e to the u is e to the u du on dx. And we want d on dx of sine of u is equal to cosine of u du on dx here. So we go back to our equation here. dy on dx here will be equal to e to the x multiplied by a differential of here sine of x plus sine of x multiplied by here d on dx of e to the x. So here it becomes e to the power of x multiplied by here cosine of x multiplied by differentiating our x1 plus sine of x multiplied by here e to the power of x becomes e to the power of x multiplied by du on dx is equal to 1 here. Becomes e to the power of x cosine of x plus e to the power of x sine of x here. And our last problem in this series here, so we're going to write out a few of our rules that we'll be using here. So we've got d on dx e to the u is equal to e to the power of u du on dx. And we see, okay, we're using our cosine function here as well. So we're saying d on dx of cosine of u is equal to minus sine of u du on dx. And we're going to look now at what this actually means here. So we split this up here. We've got y is equal e to the cosine of x plus our natural logarithm of x. So this becomes e cosine of x multiplied by e logarithm of x here. And so this becomes x e to the cosine of x here. So now this is much easier for us to work with. So dy on dx here, we're going to have x times the differential here of e to the cosine of x plus e to the cosine of x, multiplied by, should multiply in here, d on dx of x here. So it becomes x multiplied by here over e to the cosine of x here. So we write this one out here. It's going to stay as, well, it's e cosine of x multiplied by du on dx, where this is our u at the top. So multiplied by d on dx of cosine of x here, plus e to the cosine of x, and here d on dx of x becomes 1. So here this becomes x e to the cosine of x multiplied by here our cosine of x becomes minus sine of x du on dx, so our x, we differentiate our x multiplied by 1 here, plus e to the cosine of x. So we have here, we multiply this through, so here by negative signs we're going to have negative x e to the cosine of x multiplied by sine of x plus e to the cosine of x. Okay, so now looking at our function a to the power of x and its derivative. So for any number a and any real number x, a to the x is e to the x natural logarithm of a. We can go through our process here to find our derivatives, and we end up with our general terms equation here. Our differential here of a to the u is a to the u times by the natural logarithm of a multiplied by du on dx. So we go through our examples here. Again, we're going to start by writing out our formula we're going to work with. So here d on dx of a to the u is a to the u multiplied by our natural logarithm of a du on dx. So here we look at it, our a is 3 and our u is x here, isn't it? So if we go here, we've got dy on dx here is a to the power of u, so 3 to the power of x multiplied by our natural logarithm of 3 multiplied by du on dx. So u is equal to x, du on dx here is equal to 1. So here we get 3 to the power of x multiplied by natural logarithm of 3. So moving to our next question here, we've got y is equal to pi to the power of x. We'll start again, we'll write out our formula here. D on dx of a to the u equals a to the u multiplied by natural logarithm of a du on dx here. So here dy on dx will become here a to the u, so here pi to the power of x multiplied by the natural logarithm of a, which is pi, multiplied by du on dx. Our u is equal to x, so that becomes 1. So pi to the power of x multiplied by natural logarithm of pi here. For our next question here, we start again, we'll write our formula out. We've got d on dx of a to the u equals a to the power of u multiplied by natural logarithm of a du on dx there. So here we've got 3 to the power of root x here. So we go through, so dy on dx here, a to the u, so it will be 3 to the power of root x multiplied by our natural logarithm of a is 3 multiplied by du on dx, and we say, well, u is equal to root x, or x to the power of a half. Du on dx is equal to a half x to the minus a half here, or becomes 1 over 2 root x. So multiply it by 1 over 2 root x here. And we can put this together, 3 power of root x multiplied by natural logarithm of 3 over 2 root x here. And our last example here, we're going to bring in a couple of our different formulas. So we've got d on dx of a to the u is a to the u multiplied by our natural logarithm of a du on dx here. So here it's a little bit more complicated. Our a is 2, that's nice and easy, and our u is equal to sine of x. So we need to differentiate this u, so we'll bring that formula in as well. D on dx of sine of u is equal to cosine of u du on dx here. So we follow this one through, dy on dx here. So here a to the power of u, so it'll be 2 to the power of sine x, multiplied by natural logarithm of a, which is 2, multiplied by du on dx. So u is equal to sine x, du on dx here is equal to cosine of x multiplied by du on dx. And we differentiate x, and that will give us 1. So multiplied by cosine of x here.